In this video I'm going to show you a system that will automate object pooling in Unity. You can easily reuse the code for just about any game object in any project. It is written in a way that makes it easy to implement or remove stuff without breaking it. And so right now this little sample scene, it's creating enemies and heroes. Without an object pool, they're just getting destroyed. And here I have the prefab. And now if I say, you know what, I want this thing here to be pooled, all I have to do is attach this pooled object script. And as you can see, now a hero pool was created. And yeah, it's an object pool and it's working on the hero prefab. Now, of course, I can do the same with the enemy. Take the enemy prefab, give it the pooled object script. And now we have an enemy pool. And if I remove it at some point, let's do it like this, nothing breaks, it just doesn't use the pool anymore. And of course, this system is not perfect because making things more generic and automatic is going to cost you a bit of performance here and there. If you want maximum performance, you just got to go in there and tailor everything exactly to your game. But on the other hand, with this system, you're going to save a lot of development time, and so I think that's often the case, like the pros and cons of where you find that balance between how much time you want to spend on performance and how much time you want to spend on getting things done. More importantly, this is a tutorial for you to learn new things and think differently maybe. So when you come up with your own solutions, you have more tools in your tool belt. That said, you can of course just download the project from the link in the description and use it in your own games. Also, if you like this kind of content and want to support me to make more of it, please consider subscribing and liking this video. If you're new to object pools, I just made a video for total beginners, so you should probably check that out first. This one here is more for advanced users because we will be using static methods, method overloading, generic parameters and action events. But don't be scared, I will do my best to explain everything for people who are new to any of those concepts. Also feel free to ask any question in the comments, and now let's finally start. The entire system consists of 3 scripts and I'm gonna go through them from top to bottom, just a brief overview, and then we're going in reverse order in good detail. So let's start with the creator. That's basically the one that's going to replace the instantiate, the Unity instantiate with create, and the Unity destroy with kill. You can see those are static methods, so we can call them from anywhere. We don't need a reference to any creator instance. And then it just checks if an object that wants to be created is supposed to be pooled, and if yes, it checks if there is a pool, and if no, it creates a pool. If yes, it gets the right pool, and then it tells the pool, which is good old object pool. Just like tell me you got anything inactive there, give me that first. If not, create a new one. And when something gets destroyed, it tells the object pool here, you can have that back. Just put it on your list for the next time I need something. And lastly, we have the pooled object script, which you've already seen. That's the one we attach to a prefab. And it's actually pretty simple. First of all, it has a reference to the pool it belongs to, because once it gets created or taken out of the pool, it's not really connected anymore. So I have this for putting it back in there. Then we have 2 methods called activate and deactivate. Now, of course, we set the game object to active or inactive. We are also calling those events. And that's really just a handy way to create a delegate or define a delegate and create one in 2 lines. We just do it in 1 line. And make sure to include the system namespace, and then it's activated and deactivated. We're just doing that in case other components want to listen to it. It's not really needed in the system right now, but I wanted to include it because I use it quite a bit, and I think it's a handy way to make sure that other scripts or things can know that this just got activated. And you can of course make it static. Now you say public static event action, and now you know, okay, for example, when an enemy got created, you can keep track of how many. Anyhow, that's just optional. Oh, and the equals delegate and then this like empty, that's just to make sure that if we call it and no one is listening, we don't get an error message. So we don't have to do like invoke, do a null check and then do it. We can just activate it. Don't really care that no one is listening. Actually, in this project, no one is listening to it right now. Yeah, but maybe it's useful. Yeah, that's pretty much it for the pool. For the pooled object. So it sits on the prefab that we want to create instances of, and that way the creator is going to know, oh, you want that thing to be pooled. And the pooled objects are going to be handled by the pool. And it's pretty much what you expect from an object pool. First you have the prefab, that is the source that you want to create lots of instances of. And we're going to refer to everything here by the pooled object script. Because we already know if a pool is handling it, it must have this pooled object script. Otherwise it never gets in here. And then of course we have a list with all the pooled objects. So those are the ones that are taken out of the scene again. In awake, we make this a new list. Then we have the public method that returns an instance of a pooled object, where we pass in a transform as parent. And then I just made a field just a bit for readability, set it to null, and that's the one we're going to return in the end and also call activate on. And like any other pool, first we check if we have some inactive ones on our list. So if the count is bigger than 0, we get the first item. Also remove it, and then that's our object that we're going to return. Otherwise, we are going to use the good old instantiate. And I'm going to talk about this parent thing in a moment, because it makes more sense when you see it from the creator. And of course, when we create it from scratch, we also tell it, oh, by the way, this pool right here, that's the one you belong to. So the object pool, this one in the pooled object, we're setting that when we create it the very first time inside the pool. And that is important because when we return an object, or rather when an object gets destroyed, it needs to know which pool it's going to go in, and that's what the creator handles. So the creator is then going to find, oh, this is the pool you're supposed to go in if this field is set. And then the creator is going to call return object on it. And that's pretty much exactly what you expect. We add it to the list, and then we call deactivate, which is going to set the game object to inactive. Okay, and now on to the most important thing, the creator. It's class with lots of static things, and the reason it's static is that way we can call, for example, create from anywhere without even needing an instance of creator. So for example, the stage manager, where we make the new hero, we say game object new hero, and then we say Creator.Create, and that's very similar to when you call Instantiate. So now we just say Creator.Create, and see this is the name of the class and not an instance. And then we pass in a game object, which is a hero prefab. So this one's a game object. We can also use a class and pass that in, but we get to that in a moment. First, let's go through this one here. So we have a dictionary where we have a pooled object and a pool. So pool is the key, pooled object the key, and pool the value, called pools. And then we just right away make this a new one. And so this one is basically just to make sure that for every prefab that we're going to pool, we want to have a pool. And we need some way here to connect those two. So in the static method create, that's going to return us a game object. First, let's just make a new field call it new instance, set it to null. And now what we do is we take the prefab that was passed in as the source, and we see if it has this pulled object script on it, simply by saying pulled object, pulled prefab. So this is a new field. And then we just say prefab, the parameter dot get component pulled object. And the nice thing is, this is not going to return an error if it doesn't have it. Then it's simply going to set it to null, and then we can work with that. So if the pulled prefab is not equal to null, meaning, oh, okay, so our prefab has this pulled object script on it. Now what we do, first of all, we're gonna get a pull. So once again, make a new field, and then we say get object pull, and we pass in the pulled prefab. So, and I call it pulled prefab to make sure this one right now, the field, the script, is the one on the prefab. Later, we're going to use the one of the new instance. Right now, we're still working with the prefab one. So when we say get object pull, and we pass in this component of the prefab, let's see, oh, sorry, F12. So this one returns a pull, the get object pull. Pass in, make a new field again, set it to null. And first of all, we check if our pulls, our static dictionary, already has like this this component of a prefab in there. And if yes, then it's easy, we know, okay, which pull to return. It's the one that's already connected to it, so the key of that. Otherwise, we're gonna have to make a new one. So we know, oh, okay, now we just try to create a game object that out of a prefab that has this pulled object script, but our pull dictionary doesn't have any of that in its key. So let's make a container. So we just do like a new game object, and this one here is simply the name. So pull prefab.gameObject, I just use that one. So in this case, if the prefab is called hero, then we would say hero plus pull, that's the name of the new game object. Then we have our pull that we're going to return, and in this case, we're just going to add it as a component to the game object we just created. Then we're also going to tell this pull which prefab it's supposed to create. Remember, that was the very first one here. And lastly, now that we created it, of course, next time we want to have it in our dictionary. So pulls is our dictionary, and we add the pulled prefab as the key, and the pull we just created as the value. So of course, next time we pass that in, we'd say, oh yeah, I got the key here. And so the pull you want is the one that's connected to this key. And then we return the pull. So it's always going to return us a pull, and if there wasn't any, it just makes a new one. So now that we have that, the get object pull, we have a pull, and now we're actually going to create a pulled instance. So make a new field, call this one pulled instance, and then we say pull.getInstance. The pull was either created or we fetched it, and then we pass in a parent. And I'm gonna get to that in a moment. And then we just take whatever the pull they just created, that's the one we're going to return it. And otherwise, if it's not supposed to be pulled, it doesn't have that script on it, we just use Instantiate, the good old Unity Instantiate. And we just don't really care about any of that. And then we return the new instance. And before we get to that, a little preview, we have, of course, kill, and that's the one that's going to replace Unity's destroy. And so we pass in a game object, the killed object, and then we do something similar. We first check if the instance that got returned has the pulled object script on it. And so if yes, if that is not equal to null, it has one. And also, and that's important, the pulled object has its pull field. sorry, this one here is signed. So both must be not equal to null. In that case, we can say pooled object dot pool return object. So now we call this method here in the pool return object, and of course we just pass that in, gets added to the list and deactivated. And of course, if it doesn't have a pooled object script, we just destroy it the good old way. And the reason I'm checking pooled object.pool and make sure that field is not equal to null, that's really just for the cases that you place an object that's supposed to be pooled in the scene yourself, like when you build the scene. You might put some enemies in there. And thing is, in that case, they weren't created by the creator and they weren't created by the pool either. So they never went through this function, which assigns the correct pool. Actually, since the creator is all automatic, when you build the scene, the pool doesn't even exist, like the game object doesn't exist, the instance doesn't exist yet. That's all automatically. And of course you would get an error there, because then you say, sorry, what was it? Because then you would call this pooled object.pool and you want to return it, and it says, I have no idea which pool I'm supposed to go to. And of course, you can write your own way around that. I just figured, you know, this doesn't happen that often, and it's not that important when you picture like a whole game. Like, okay, you have maybe a few enemies in there, then okay, just destroy those. But all the other like thousands and thousands, they're going to be pooled. And of course, totally up to you. And now this is pretty much the system. Now let's go over some details I left out. And so the first one is the transform.parent. And here in the parameter it says equal null. And that way it's an optional parameter. I give it a default value of null. And that means I can call Creator.Create and only pass in a game object. In that case, it's just going to take null whenever I use parent here. It's going to take the default value. But if I call it, pass in a game object, and also transform, then it's going to override this null default value and use whatever I passed in when I called this method. And the reason is that, first of all, I want by default all objects to be parented to the pool, just to, you know, tidy up the scene a bit. And so if we call this without passing in anything, it's going to be null. And that means it's going to call the pool.getInstance, and it's going to pass in null. And that's where the pool actually checks it. Now, so we have null here because nothing was passed in. And when it instantiates the prefab, or the instance, sorry, of the prefab for the first time, then what we're going to do is we make a transform new field, new parent. And in case you've never seen this, this is an if-else statement all in one line. So what we're doing here is we're saying new parents equals to, and then we check for a condition. Is parent equal to null? If yes, we're going to take this value and assign it to a new parent. If this condition is false, we're going to take the second one, the parent, and assign that as a new parent. And of course, transform here, that's referring to the transform of the pool, like whatever the game object this pool is attached to. So if it's null, we say, okay, the pool is just going to act as the parent. And otherwise, we might be overriding that. And the reason for doing that is pretty much that I want to use it for UI elements as well. So for game objects, you could just say like Creator.Create, and then in the next line, whoever creates it sets the parent itself. So maybe the stage manager would say, I want to be the parent. And it could just say Creator.Create, give me this. And then in the next line, like new enemy.transform.setParent, pass in this one. Wouldn't be a problem. But when you create UI elements and you instantiate them and then in the next line you set the parent, you might end up with quite a mess because they might be parented to something that doesn't have a canvas, and that can really mess up the layout. And then in the next line you parent them to something that has a canvas and the layout is still messed up. And so for this I want to be able to call instantiate and pass in a parent that has a canvas right here, because if I pass it in right there in this method, it's not going to get messed up. And that's really just the reason. And now the bonus, of course, is you can call this in one line. If the stage manager says I want to be the parent, you could say in here Creator.Create, instead of just passing in the game object, you could override the parameter of transform and say transform, which is the transform of this script. And now there is one last thing, which is a static method that takes in a generic parameter, and it's also called create. And the reason I did that was because, for example, when you have the stage manager, you might have a prefab that you're referring to by a script that's attached to it. That's quite common. So if you already know, okay, enemy is the most important script, I want to refer to the prefab right away by enemy, don't have to use get component. But other times you might not even have a script you want to refer to, and you just say game object, like hero prefab. And I want the Creator.Create method to work with both. And it's actually pretty similar to the original instantiate. So if you double click it, hit F12, you can see here public static T instantiate T original, apparent, and condition for T is it has to inherit from object. Or sorry, it has to be an object. Unfortunately, you can't really go into the original code here. From what I've heard, it's quite expensive to get a look at that. And I was trying to do it all in one method and it was getting pretty messy. So I decided, what, I'll just use two methods, and by using overloading, meaning I can have a method with the same name or multiple ones, as long as the parameters are different, the script is just going to figure out when I call Creator.Create which one I want to use. If I pass in a game object, oh, it's this one. If I pass in a component, then it's going to use this one. And so T is just like it's a generic, so it can be anything. And here I made the condition, it has to be a component. So anything that gets attached to a game object can be passed in here as T. And when I pass in a prefab, that's basically when I define what T is. So it could be a class like the enemy. So when I call Creator.Create and I pass in enemy prefab, it's an enemy class, you know, oh, T is an enemy. So that's what we're going to return to, an enemy instance. And so we can say T new instance equal to null. And here we're doing the same. We're saying pulled prefab, check if it has the component. And we can just say prefab.get component pulled object. It's just the same. It says, oh, okay, I assume you want like other components on the same game object that T is attached to. And so, yeah, that works quite nicely. Everything here is the same. The get object pool, get one or create one. And the slight difference here is where we say return pooled instance. We don't return a game object, we return pooled instance get component T. Once again, T is defined when we call it, so it's going to return that. And otherwise, we just use instantiate. And as I just showed you, instantiate 2 can take in anything. It can be game object or a component. And then we're going to return the new instance. And then of course we want that for kill 2, which I don't have. So I figured maybe you want to do that as a little exercise on your own. So make sure that there's another kill method that takes in a generic parameter and then it's kind of similar to this one. It's actually even a tiny bit easier to write. So yeah, maybe do that as an exercise. If you think like, I really want to know how that works and I can't figure it out, let me know in the comments. And of course, if you have any kind of question, feedback, criticism, just let me know. Also, I'm always open to new ideas on what to make tutorials for. I just got a Quest, so probably going to do some VR content. And I think the next video is going to be me announcing that I'm going to do Unity 101 coaching, which is going to be free. So if you're interested in that, make sure to subscribe, look out for that. And otherwise, thanks for watching and goodbye.